Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. Today I am here to give a presentation on Unit 1 on linear algebra and calculus, and Unit 1 is, these are the topics which I am going to cover in this lecture: matrix definition, real matrices, symmetric matrix, skew symmetric matrix, orthogonal matrix. These are all types of real matrices. And coming to complex matrix, Hermitian matrix, skew Hermitian matrix, and unitary matrices. These are the three complex matrices, and problems on Hermitian and skew Hermitian matrix. First, let me introduce what is a matrix and its definition. So, definition is a rectangular array of mn numbers, where m represents number of rows and n represents number of columns. That is an order m by n. We write it as m cross n, but we read it as m by n, right? So, in general, an m by n matrix is usually written as A is equal to A11, A12 and so on, A1n. So, this represents the position of elements in the matrix. A12 means this is a position of first row, first column. In general, we write it as Aij, where I represents for number of rows and j represents the position of columns. So, A11, A12 and so on, A1n. This is the first row, which is R1. Similarly, A21, A22 and so on, A2n. These are second row elements, which R2, like that. So, in general, we represent capital A is equal to Aij, where the order of the matrix is m by n matrix. And then elements A11, A12 and so on, etc. These are the elements of the matrix capital A, where Aij belongs to ith row and jth column. In general, we are writing Aij means I represents rows and j represents columns. Now, let us see what is a symmetric matrix. A square matrix capital A equal to Aij is called symmetric matrix if Aij equal to Aj for every I comma j. Means A12 equal to A21, A13 equal to A31. In general, Aij equal to Aji. Let us see one example. A is equal to 1, 2, 3, 2, 4, 5, 3, 5, 2. This is a 3 by 3 matrix. The dimension of this matrix is 3 rows and 3 columns. So, how to check whether this matrix is symmetric? We can also write this as A transpose is equal to A. Then we say that A is symmetric matrix. A transpose means interchanging rows and columns. So, what you'll get A transpose here? First row I am writing as first column, say 1, 2, 3. Second row 2, 4, 5 I am writing as second column. Third row elements I am writing as third column elements. So, this is equal to again the original matrix capital A. So, A transpose equal to A, we call the given matrix as symmetric matrix, right? Next, coming to skew symmetric matrix. Square matrix capital A equal to Aij is called skew symmetric if Aij equal to minus Aji for all values of I comma j, or we can also represent a skew symmetric matrix as A transpose is equal to minus A. Then we say that the given matrix A is called skew symmetric matrix. Let us see one example. A matrix, consider 0, 2, 1, minus 2, 0, 3, minus 1, 3, 0. So, what is A transpose? Let us interchange rows and columns. First row I am writing as first column. Second row I am writing as second column. Third row elements writing as third. This, let us take minus common in every element. So, 0, 2, 1, minus 2, 0, minus 3, minus 1, 3, 0. So, this can be written as minus A. So, A transpose is equal to minus A. So, we call the given matrix A is skew symmetric. So, symmetric matrix, skew symmetric, these are the two real matrices, right? We can observe in skew symmetric matrices, the principal diagonal elements are always zeros. Next, coming to another type of matrix, orthogonal matrix. Let us see what is orthogonal matrix. A matrix is said to be orthogonal when the product of matrix and its transpose, product of the matrix and its transpose means A into A transpose gives identity value which is equal to I. So if A into A transpose equal to I, we say that the given matrix A is orthogonal. Let us determine the matrix whether it is orthogonal or not. Say A equal to -1 0 0 1. First find A transpose and multiply with the given matrix A. So here A in transpose means first row I am writing as first column, second row I am writing as second column. Now let us multiply both the matrices. A into A transpose. A means -1 0 0 1 -1 0 0 1. A into A transpose we get identity matrix of 2 by 2. So we say that the given matrix is orthogonal. Next, coming to complex matrices, there are different types of complex matrices. First one is Hermitian matrix. A square matrix capital A equal to Aij is said to be Hermitian if A conjugate whole transpose equal to A. First find the conjugate, then find the transpose. That should be equal to A. Or we can also first find the transpose of the matrix, then find the conjugate. Both are equal, that should be equal to A. Then we say that the given matrix A is called Hermitian matrix. We can also represent this with A power theta. Few authors will represent like this. Theta means conjugate transpose. First find the conjugate and then transpose. Both the operations we can represent by theta. Let us take one example. A equal to 2, 3 plus 4i, 3 minus 4i, 5. How will you write A conjugate? A conjugate is denoted with A bar. While writing the conjugate of any complex number, make sure that you change the sign of imaginary coefficient, not the real part. Here real part is 2, write down as it is. 3 plus 4i. What is the conjugate of 3 plus 4i? Only change the sign of imaginary value 3 minus 4i. Next, 3 minus 4i conjugate, 3 plus 4i. 5 is the real part, no need to change the sign of it, write as it is, 5. Now, after finding the conjugate A bar, find its transpose. A bar whole transpose. Transpose means you all know interchange rows and columns. So, first row I am writing as first column, second row 3 plus 4i, 5 writing as second column. Check whether this matrix is equal to this matrix or not. 2, 3 plus 4i, 3 minus 4i, 5. This is equal to A. So we get conjugate transpose is equal to A. So we call it as Hermitian matrix. Right. Now let us see one more type of matrix, skew Hermitian matrix. A square matrix capital A equal to Aij is said to be skew Hermitian if A conjugate and whole transpose equal to minus A. Or we can simply write A power theta equal to minus A. That is A transpose whole conjugate or conjugate transpose, both are same, that should be equal to A. Sorry, minus A. Let us take one example, check whether the matrix is skew Hermitian or not. So B equal to 3i, 4 plus 5i, minus 4 plus 5i, minus I. First of all, we find the conjugate of the matrix, then find the transpose. So conjugate is denoted with B bar, that is conjugate of 3i is minus 3i. Conjugate of 4 plus 5i is 4 minus 5i. conjugate of minus 4 plus 5i, only we change the sign of imaginary value. Minus I can be conjugate is I. Now find the transpose B conjugate whole transpose, that equal to minus of B. So we say that the matrix B is skew Hermitian matrix, right? Let us check one more problem on Hermitian matrix. The matrix A is given like this. We check whether the matrix is Hermitian or not. So first find the conjugate of this matrix. So A conjugate is denoted with A bar. Real part as it is, I can be written conjugate is minus I. Conjugate of 3i is minus 3i. Minus I conjugate is I. 0, 2 plus I. Minus 3i conjugate is I. 2 plus I conjugate 2 minus I minus 1. Right? This is how we find the conjugate of a matrix. Now find its transpose. A conjugate whole transpose. First row I am writing as first column. Second row I 0 2 plus I am writing as second column. Third row 3I 2 minus I minus 1. Is this equal to the original matrix capital A? Yes. So this is equal to A. Therefore A is Hermitian matrix. Right. Now we have another type of matrix, another unitary matrix. A square matrix capital A is said to be unitary if A conjugate whole transpose equal to A inverse. We can also write this as A conjugate whole transpose into A equal to I, or A power theta into A should be equal to I. So first find conjugate, then find its transpose, then multiply with the A. It should be, the resultant matrix should be identity matrix. Then we say that the given matrix A is unitary matrix. Now let us check whether the matrix C is equal to 1 by 2 I by 2, 3 root 3 by 2, root 3 by 2 and 1 by 2 into I. First find the conjugate of this matrix, which is given by C bar equal to minus 1 by 2 into I, root 3 by 2, root 3 by 2 and minus 1 by 2 into I. Then find the conjugate transpose, C conjugate whole transpose. So let us interchange the rows and columns. We get this. So A conjugate whole transpose equal to A inverse. Here we are representing with C. So I have to prove that C conjugate whole transpose is equal to C inverse. Then we can say that the matrix C is unitary matrix. So this is equal to C inverse. Therefore C is unitary matrix. Right. So this is our topics which we have covered in this class. Matrix definition, symmetric matrix, skew symmetric matrices, orthogonal matrix, Hermitian and skew Hermitian matrix, unitary matrix. These are all different types of matrices we have covered in this. Next lecture we are going to cover echelon form, normal form and Gauss-Jordan method. Thank you.